All right, so our next topic that we're going to be covering is series notation. So this you'll also your calculus and your statistic classes. That's how we're covering these. So a series is a sum of terms in a sequence. That's what we did before with, a sequence is what we were doing before. And so this is what your sequence looks like, 1, 3, 5, 7, 9. And your series is when you try to add up these numbers. So 1 plus 3 plus 5 plus 7 plus 9. That's the difference between what we're doing today and what we did yesterday. All right, so here the sum of certain numbers of terms of a sequence is described using Greek letter sigma. So your Greek letter sigma is this one right here. Kind of looks like an E-ish, I don't know, I would say. And then you have your first value. So the K is your first value for K. And then N would be your last value. Okay, and it'll make a little bit more sense when we start working out some of these problems. And then your sequence rule is your f of k. Okay, so it's like a little function. And so if we look at this first one, it says write the series in expanded form. So since we're writing it in expanded form, if you notice here, we want to start at k equals 1 and we want to start at k equals 6. So we're going to have 1, 2, 3, 4, 5, and 6. And since this is a series, okay, we are going to be adding these up. So plus, 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 and plus. All right, and so our function rule is 3k plus 1. So 3k plus 1. 3k plus 1. So I'm leaving the k blank for right now. 3k plus 1. 3k plus 3k plus 1. And so our k, if you notice here, they want us to start at 1 and they want us to end at 6. So we'll go 1, 2, 3, 4, 5, and 6. So if you look at the first one, we're going to go ahead and multiply this out. 3 times 1 is 3, plus 1 gives you 4. Plus 3 times 2 is 6, plus 1 is 7. Plus 3 times 3 is 9, plus 1 is 10. Plus 3 times 4 is 12, plus 1 is 13. Plus 3 times 5 is 15, plus 1 is 16. And last, 3 times 6 is 18, plus 1 is 19. Okay. Now they want the expanded form, so this is our expanded form. They don't want us to actually add it up, so that's it. We're done there. All right, so let's try the next one. So this time, if you notice, n equals 3, so that means they want us to start at 3 and they want us to end at 5. So 3, 4, and 5. So there is only 3 terms in this series. Okay, remember the sigma stands for we're adding them together. And then we go ahead and take our function rule. So it's 1 plus n squared. And notice how I leave a blank for n. So 1 plus n squared. 1 plus n squared. And in that n, we start off, they want us to start at 3. And they want us to end at 5. So 3, 4, and 5. Okay, so let's go ahead and multiply this out. So 3 squared gives you 9, plus 1 is 10. Plus 4 squared is 16, plus 1 is 17. 5 squared is 25, plus 1 is 26. And that's it for this one. Okay, because they just want us to expand it. All right, now they want us to find the indicated sum. So if we look at the first one, they actually want us to find the sum. So here they want us to start at 1 and end at 6. So we're going to have 1, 2, 3, 4, 5, and 6. And we are going to add all of these up. Plus, plus, and plus. Then we have our function rule, 4n plus 1. So 4n plus 1. 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 Oh, the 1 doesn't fit here. There you go. There. Alrighty. And then since they want us to start at n equals 1 and all these blanks that I left for n, I'm going to start at 1, then 2, then 3, 4, 5, and I should end at 6. They tell us here. And then we actually multiply these out. 4 times 1 is 4, plus 1 is 5, plus 4 times 2 is 8, plus 1 is 9, plus 4 times 3 is 12, plus 1 is 13. 4 times 4 is 16, plus 1 is 17. 4 times 5 is 20, plus 1 is 21. And last, 4 times 6 is 24, plus 1 is 25. And we go ahead and take all these numbers and plug them into the calculator, and they give us 90. All right, the next one. So here they want us to start at k equals 1 and then stop at 3. So 1, 2, and 3. Okay. We are going to be adding all of these up together. Here is our function rule. So 2k plus 1. So 2, and I'm going to leave the exponent blank, plus 1. 2 to the power of blank plus 1. 2 to the power of blank plus 1. Okay. And then our k, we are going to start at 1 and go all the way to 3. So it can be 2 to the first power plus 1, 2 to the second power plus 1, 2 to the third power plus 1. So 2 to the first is 2 plus 1 is 3. 2 squared is 4 plus 1 is 5. 2 cubed is 8 plus 1 is 9. And then we go ahead and add these up. 3 plus 5 plus 9 is going to give us 17. All right, this next one. Now they want us to use sigma notation to write the given sum. So if we look here, we are writing our own sigma notation. Okay. So we're going to see, what does our k start at? Okay, what number are we starting at? So if you notice, the variable that's changing here is 3, 4, 5, dot, 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 all the way up to 15. So that means that they want us to start at 3 and they want us to end at 15. Okay. Go ahead and erase that. It got kind of messy. All right, now we need to write the function rule. So if you notice, all this section up here, they're all ones, and then they all have this 5 in common on the denominator. So that is our function rule. It's going to be 1 over 5, and what changes is our exponent. It's 5 to the power of k. And that's it. That would be our sigma notation. Go ahead and try the next one. Here we have 3 to the 10th power plus 3 to the 3 to the 10th, 3 over 10, I'm sorry. 3 over 100, 3 over 1,000, 3 over 10,000. So this one's a little bit more difficult to see as far as what number we're starting with and what number we're ending with. Okay. So let's go ahead and see what we do have in common. So we have 3's all at the top. So I'm going to go ahead and write a 3 in the numerator over, and then the denominator, we don't know what that is, but if we do notice, this first term right here is 10 to the first power. 10 times 10, 10 to the second power gives you 100. 10 to the third power gives you 1,000. 10 to the fourth power gives you 10,000. Okay, so then that means that we are starting at k equals 1 because our 10 is to the first power, and we end at 10 to the fourth power. So then I'm going to erase this so it doesn't get so messy. This should be 4. So then it's 3 over 10 to the power of k. And that's where I'm going to stop for today. If you have any questions, go ahead and shoot me an email, leave it down below in the comments, or stop by my office hours. Thank you guys for watching. Bye.